Hello, everybody, and welcome to the Unit 3 review session. Unit 3 focused on naming and formula writing, of chemical compounds, okay? Your test format is going to be 10 multiple choice questions. Then you will have 2 calculations. Then you will have 10 where I give you the name and you're going to have to give me the formula. I'm going to have 10 where I give you the formula and you're going to give me the name. All right, so that is your test format for this test. Let's talk a little bit before we get into the actual practice problems, just about naming compounds in general. All right, when you are given a compound, you should ask yourself the following questions. Okay, so whatever this compound is going to be, does this compound start with a hydrogen? Is it a metal? Or is it a non-metal? Those are really the options that we are dealing with, okay? So, starting with hydrogen, and it's not water, it's not H2O. All right, if you're starting with hydrogen, and it is going to be an acid, and you're gonna have to name it accordingly. There's 2 types of acids when it comes to naming. There are binary acids, and that's gonna have a hydrogen and then a negative ion, all right? But it's only gonna have 2, okay? For binary acids, you're gonna start with hydro, then the root of that non-metal here, of that negative ion, it's gonna end in ic, and then the word acid, okay? If that is for binary acids, that's the only time you use that hydro prefix. If it is a ternary acid, that means the name is based on the polyatomic ion. All right, and if that polyatomic ion, and remember, because this is gonna come up a lot, you're gonna have your polyatomic ion sheet that'll look similar to this. It might not be exactly the same. You're given all of these, but you do need to know when to look for them. So it's a really good idea to read over these several times. All right, so the name of a ternary acid is based on that polyatomic ion. If the ternary acid ends in, if the polyatomic ion, ends in 8, the acid is going to end in ic. If the polyatomic ion ends in 8, the acid will end in us. All right, so that's really, there's a little saying that goes along with that. Ic, I ate and got an itis. So again, starting with hydrogen, you are going to be an acid, except for when you're dealing with water, of course. All right. The naming that we spend a lot of time on is if your compound starts with a metal. Let's just remind you, okay, when looking at your periodic table, there's this stair step, okay? Anything to the left of that stair step is considered a metal. Everything to the right is considered a non-metal. If the compound starts with a metal, that means that you are dealing with an ionic compound. And these compounds are all about those charges. We're balancing out those charges to give us a total of 0 because compounds by definition are neutral. All right. Now, if that metal is what we call a regular metal, and it is really important that you know your regular metals. Who are the regular metals? They are group 1, column 1, group 2, aluminum, zinc, and silver. Group 1 metals will always have a positive 1 charge. Group 2 will always have a positive 2 charge. Just aluminum, not its group, just aluminum will have a +3. Just zinc from its group will have a +2, and just silver will have a +1. Okay, so again, looking at your periodic table, group 1 is always +1, group 2 is +2, sorry about the glare there. I'll try and hold this up. Then we have aluminum, zinc, silver. What's nice is they're diagonal in a line, plus 3, plus 2, plus 1. Really important that you memorize those regular metals, okay? If you are a regular metal, you just simply name that metal and continue on with your naming. If your metal is a transition metal, all right, so these are all other metals for purposes of naming. All other metals are considered transition. You are going to need to have a Roman numeral in the name to tell the charge. Again, it's not telling how many, it is telling the charge of that transition metal. Because transition metals, again, anything that is not group 1, group 2, aluminum, zinc, and silver, can actually have some charges that change, so the name has to tell them that. Finally, if you look at your first element in the compound and it's a nonmetal, and it starts with that nonmetal, that means you're dealing with a covalent compound. And these are the easiest to name and write the formulas for, because this is where we use those prefixes. All right, the prefixes are great, but you don't want to fall in love with them too much because they are only used for covalent compounds. All right, at this time, if you'd like to try the problems on that review session sheet, it might be a good idea before I go over them, or you can just wait and go over them as I go over. All right, so let's look at number 1. First thing I always ask myself when I'm naming any compound is, first element, is it a metal or is it a non-metal? Okay, I'm going to look at my periodic table. I'm going to find titanium. All right, I see titanium's to the left of the stair step. It is a metal. Then I say, is it regular or is it transition? Well, regular is group 1, group 2, aluminum, zinc, and silver, so it is transition. If it's transition, it is my job to figure out the charge, because the charge has to go in the name. We're going to figure out the charge by looking at the negative ion. We always know the charge of negative ions in an ionic compound. As we learned last unit, and again this unit, group 17, everything in 17 has a -1 charge. Group 16 is -2. 15, nitrogen, phosphorus, and arsenic are -3. So again, group 17, -1. Group 16, -2. Group 15, the nonmetals of 15 are -3. So titanium, all right, we know that the name is going to start with titanium, but I have to figure out what that Roman numeral is going to be. Iodine has a charge of -1. There are 4 iodines, so I have a total of -4. There's only 1 titanium here. Therefore, that titanium is the only thing bringing the positive charge. It has to bring all of the positive charge. There's just 1, so that positive charge has to be +4. +4 and -4 give you 0. That's how we get a neutral compound. So if it's +4, Roman numeral for 4, all right, 1V. So titanium, and then we read it, titanium 4 iodide. All right. The next thing, let's go on ahead and look at our next example. We're looking at cobalt. Again, you're going to look at the periodic table. Is cobalt a metal or a non-metal? Cobalt is a metal. Is it regular or is it transition? Cobalt is right here in the middle of your periodic table, so it is a transition. Our job is to figure out that charge. Well, we know nitrogen's charge. Nitrogen is a non-metal in group 15, so it's -3. -3 times 2 gives you -6. That means that the total positive charge has to be +6. You're going to ask yourself, well, what times 3, because there's 3 cobalts here, what times 3 is going to give you +6? And that is going to be +2, because again, +2 times 3 gives you +6. So I am cobalt 2 nitride. All right. Both the iodine and that nitrogen, we change those endings to IDE. Next up, magnesium. All right. Is it a metal or non-metal? It is a metal. Is it regular or is it transition? It is regular. Magnesium is in group 2. That is a regular metal. Regular metals do not have a Roman numeral because it's always +2. So there's no need for it. So you just simply write the word magnesium, and then phosphorus turns into All right, magnesium phosphide. All right, let's look at number 4. Number 4, I look at it, first element is hydrogen. That means it's an acid. All right, this is an acid with 3 elements. It means it's ternary. This is going to be based on a polyatomic ion. I'm going to look for the polyatomic ion NO2. NO2 right here is nitrite. Nitrite. That ends in ITE. So it goes to us, and this becomes nitrous acid. Please make sure you always have to have the word acid there. All right, number 5. Sulfur, metal or nonmetal? It is a nonmetal. All right, when you start with a nonmetal, that means that it is going to use those prefixes. So I am sulfur. We don't use the mono on the first one. So sulfur, and then 3 is tri, so trioxide. We do still change those endings to IDE, even for the covalent compounds. Number 6 is an interesting one, and one you just kind of have to keep an eye out for. NH4, you need to recognize that that is the polyatomic ion ammonium. All right, that is ammonium, and you need to name accordingly. So I am ammonium. OH is another polyatomic ion, and you're going to find it on here. It is hydroxide. It is hydroxide. So just simply ammonium hydroxide is the name. There's not going to be any Roman numeral, nothing like that. That's one of the few cases where you have 2 polyatomic ions together. Okay. All right, number 7, aluminum, metal or nonmetal? It's a metal. Regular or transition? It is regular. So we're just going to go ahead. Aluminum. And then CN is a polyatomic ion. I'm going to look to double check. CN is cyanide. Don't change the name of anything, so just aluminum cyanide. Okay. All right, let's move on to number 8. Okay, so number 8, I'm starting with beryllium. Beryllium is a metal. It's to the left of that stair step. It is a regular metal. So we're just going to go on ahead and write beryllium. You do not need a Roman numeral with this. All right. CH3COO, that is a polyatomic ion. All right, it is the polyatomic ion acetate. It can be written either way. Either way is perfectly accurate. All right, so, but name-wise, it's always acetate. So beryllium acetate. All right, now let's do something that's going in the other direction. Now we're going to be going from name to formula, and this is where you really have to keep in mind those charges. All right, so sodium phosphide. Sodium is in group 1, so it is +1. Phosphorus is -3. Again, this is all based on the polyatomic ions. I'm sorry, this is all based on the periodic table. I'm so sorry, periodic table. Sodium is +1. Over here, nitrogen in group 15, or phosphorus in group 15 is -3. So that means I'm going to need 3 sodiums to go with that phosphorus, so Na3P. Number 10, carbon tetrafluoride. Carbon's a nonmetal. This is a covalent compound. No prefix on that first one means it's just 1. So C, tetra means 4, F4. All right. Number 11, lead-2 sulfite. Lead-2 means that lead is +2. Sulfite is a polyatomic ion with a -2 charge. So Pb, and then sulfite is SO3. Polyatomic ions, do not put parentheses around them unless there's more than one. In this case, there's just one sulfite. Sulfite is SO3. There's just one. We just write it like that. Next up is calcium phosphate. Calcium is in group 2, so it is +2. Phosphate is a polyatomic ion that has a charge of -3. They need to come together. 2 and 3, the least common multiple is 6. So you're going to say to yourself, how many calciums do I need to get to be +6? All right, so I need 3 of those, because 3 times 2, +2 is +6. And then how many phosphates? I need 2 phosphates. Now I use my parentheses. Phosphate is PO4, and I need 2 of those to give me a total of -6. So Ca3PO4 2. Ammonium, we've already talked about, is a polyatomic ion with a +1 charge. Sulfate is a polyatomic ion with a -2 charge. A little hint, anytime you see the endings ate and ite, that means look on your polyatomic ion sheet, all right? That means they are polyatomic ions. In this case, I need 2 ammoniums to go with my sulfate. So NH4 is what ammonium is. I'm gonna put that in parentheses and put a 2. And then SO4, ammonium sulfate. All right, let's do a couple more. We have silver cyanide. Silver is one of our regular metals at +1. Cyanide is a polyatomic ion. All right, it doesn't end in H or ite, but it's still a polyatomic ion with a -1 charge. So these just go together 1 to 1. So Ag and cyanide is Cn. All right, aluminum sulfide. Aluminum, regular metal with a +3 charge. Sulfur is group 16, so that's a -2 charge. We have another situation where we have our least common multiple being 6. So I need 2 aluminums to give me +6, and I need 3 sulfurs to give me -6. All right. Copper 1 arsenide. Copper 1, that 1 is telling me that copper has a +1 charge. Remember, the Roman numerals are there to tell you the charges. Arsenic, all right, this is arsenide is arsenic, and that is a -3 charge. It's in the same group as nitrogen and phosphorus. So I'm going to need 3 coppers to go with my arsenic. So Cu3As. All right, and our last practice one to do is carbonic acid. Well, you know it's an acid, all right, because I'm telling you. And so that means I'm going to have hydrogen. Well, hydrogen is going to be +1. In all acids, hydrogen has a charge of +1. Carbonic means that that came from 8. So I'm looking for the polyatomic ion carbonate. All right, and when I find carbonate on my periodic table, okay, carbonate is CO3. It has a -2 charge. So I have H plus, and then I have CO3 2 minus. So I need 2 hydrogens to go with that carbonate. So I am H2CO3 is carbonic acid. All right, fantastic. Let's do the last 2 where a little bit more math comes in, and this is where you will need your calculators. Okay. Number 18 on the review session sheet, calculate the percent composition by mass of copper in copper 2 phosphate. So first thing, all right, copper 2 means that that copper is +2. Phosphate is a polyatomic ion that is -3. All right, so again, a least common multiple of 6, it comes up a lot. So I need 3 coppers, so Cu3, PO4, 2. All right, so there is my copper 2 phosphate. Now, masses. Remember, we're going to use the masses from our periodic tables. Always have a tenths place. Sorry, this is a little out of focus. Always have a tenths place when dealing with these average atomic masses from the periodic table, and you should be in good shape. All right, we're going to go through and show all of the work for this. So first you have copper, then you have phosphorus, then you have oxygen. Copper has a mass on the periodic table of 63.5. Again, I'm getting those from the average atomic masses on the bottom here of each of those elements. Always have a tenths place. Phosphorus, 31.0, and oxygen, rounded to have a tenths place, is 16.0. Coppers, you have 3, so you're going to go 63.5 times 3, and that gives you 190.5. Phosphoruses, you have 2, because that 2 distributes, and that gives you 62.0. And then oxygens, there's 4 oxygens in a phosphate, but you have 2 phosphates. So again, you're just using math skills here, 2 times 4. So that is 16 times 8, and that gives you, all right, 128. So 16 times 8 gives you 128. You're then going to add all of those up. And when you add those up, you get the formula mass of 380.5 AMU. Now, I didn't just ask for the formula mass. I want to know the percent composition of copper in copper 2 phosphate. So this is the total. Copper gave me 190.5. I'm going to divide that by my total, and I'm going to multiply that by 100. When I do, I find about 50.1%. Also, always have a tenths place when you're dealing with your percentages. So all this number tells me is that by mass, this is made up of about 50% copper. Okay. All right, last problem. And this is what we're doing our lab on, something that are called hydrates. All right, what is the percent water in aluminum nitrate hexahydrate? So remember, a hydrate is an ionic compound, in this case aluminum nitrate, that has a certain number of waters attached. Okay, in this case, hexa, 6 waters. That means 6 waters. So the first thing you're going to do is write the formula. Aluminum has a charge of +3. Nitrate is a polyatomic ion with -1 charge. So I have AlNO3, 3, because I need 3 nitrates to go with my aluminum. Now, dot. And again, this is a dot. It's not a multiplication sign. It's just simply a dot. Hexa is 6, so that is 6 H2O. We do use a full number coefficient here in front to tell us the number of waters. Now, I want to know what the percent water is, so I need to know the masses of everything. So I have aluminum, I have nitrogen, I have oxygen, and then in these types of problems, it's a good idea just to leave water as one thing instead of separating it. All right, so aluminum has a mass from the periodic table of 27.0. There's just one of those. All right, nitrogen is 14.0. You want to include those point zeros, even if there's 0, but you're showing me that there's a tens place. There are 3 nitrogens, 1 in nitrate, but you have 3 nitrates, so that's times 3. So that gives me 42.0. Oxygen is 16.0. There are 9. 3 times 3 is 9. All right, so that gives me 144.0. Water, as I said, leave water by itself. Water has a mass of 18.0, 16 from the oxygen, 2 from the hydrogen. It's always going to be very helpful to know that water has a molar mass of 8, or a molecular mass of 18. We just use it a whole lot. And in here we have 6 waters, so times 6. All right, which gives us 108. You're going to add all of those up. Okay. When you do add all of those up, you get a total mass of 321.0. Now the question was, what is the percent water? So now what you're going to do is take the mass of water, which is 108.0, divide it by the total, which is 321.0. You're then going to multiply it by 100, and your percent is about 33.6%. All right, I hope this was helpful, and good luck on your test. Take care.